Assalamu alaikum everyone. So we're going to start with the first lecture in our online lecture series, and we had done introduction to surveying, so I'm not going to start with that. So I'm going to start with the next topic, which is methods of linear measurement. So we have done some methods in the lab as well. So you have used pacing to measure linear distance, horizontal distance, and you also use measuring tape. So we'll discuss measuring tape in detail, and we'll also see what are some other methods that are now being used to measure linear distances. So first we come to direct measurement. So you have done pacing and you have used measuring tape. Chaining is a similar process. I'll get to that and to other processes as well. But let's first talk about some other methods some of which you will be using in this course and some of which you will be using in the next semester. So in optical measurement, we have theodolite and total station. So these are the instruments which are primarily used for measuring angles, but by some modifications, you can use them to measure distances as well. So they come in very handy because when you actually execute survey in the field, you need to measure both. And instead of carrying different instruments or when the terrain is difficult, it gets very tedious to measure distance using a measuring tape. But using these instruments, it gets really easier, and you will see later on how they are used for that. And then we have some modern instruments like EDM. EDM, again, we'll cover this in the next semester, but just a brief overview. EDM is an instrument that uses a laser and a reflector to measure distance. So basically, it points a laser towards a reflector and it measures the time the laser took to strike the reflector and then come back. And then by using the basic formula of speed, you can calculate distance. And then you have the another modern instrument, a GPS. So a GPS can give you coordinates in terms of latitudes, longitudes, and altitudes. And then by performing calculations on them, we can measure horizontal distances. One other method, which is not explained over here, that we will also see in the next semester, that is finding out distances using photographs. So if you have a photograph which is taken from the top, which basically shows you a plan view of an area. So if you know the scale, you can use the photograph to find out distances like you do on a map. So pacing is something that you have done in the lab and you're very familiar with this. So in pacing, what you do is uh, you set out two pegs or two ranging rods, basically 2 points between a specific distance, and that distance is known. And then you walk from one point to the next and you count the number of steps that you took. Just by dividing the distance by the steps you took, you get your pace length. That is the distance you cover when you take one step. And then when you know that, you can quickly find out distances by walking on that path, and that gives you um, a method which you can use when you don't have any other instrument, or when you're not interested in very accurate results, you just want a rough idea, so you can use this method. Pesometer is an instrument that counts the number of steps automatically. So this is a modification of or from the same family of instruments that is used in smartwatches or those fitness bands that calculate the number of steps. And then we have speedometer. We all know how that works. So it calculates the number of revolutions of the wheels and then it gives you distance. Perambulator is similar instrument. So you scroll it along the path for which you want to measure the distance, and then you measure the count the number of revolutions it took, and the circumference is known, and then you can calculate distance. So these are some of the old methods. And then chaining. So chaining is a term that is used both for finding out distance using this metallic tape, measuring tape that you use. But in older terms, as you can see in this picture, so they used to have these chains which were of equal length tied together and then stretched on the path whose distance you want to find out. And then by counting the number of these links, you can calculate distance. You could calculate distance. It's not used that much now. So ranging rod is basically a rod which is used to determine the location of a point, so it's visible from far distance. So this is used in leveling. This is used in total light reversing. So whenever you want to set out points, you use this. So chain, like we discussed already, so you tie them together and you count the number of links that you used. So you can read this up. I won't go much into this. This is very self-explanatory. Some other instruments that you already know why they are used, and you have used them in the lab. So ranging. Uh, Ranging is a process in which you set out intermediate points between a straight line. Oops. So when you want to find out distance between 2 points, or yeah, so when you want to find out distance between 2 points, or you want to set out points whose distance is large, so usually your measuring tape is usually 30 meters. Uh, and if you want to set out larger distances, so then you need to locate intermediate points between those two actual points. So that process is called ranging. So it basically helps you in aligning your direction properly, and that process is known as ranging. So we have two different kinds: direct ranging and indirect ranging. So direct ranging is done when the 2 points, the first point and the last point, they are intervisible. So when you're standing at point A, which is your first point, you can actually see the point B, which is your second point. So as you can see over here, so if this observer is standing at this point A, if by standing over here he can see this point B, so then the process of ranging that he will use would be called as direct ranging. So what needs to be done is that intermediate points need to be set out on this path. The distance between these intermediate points depends on the length of the measuring tape or the usage. Why do you want to do ranging? So it depends on that. So how it's done is that one person holds a ranging rod and stands between those 2 points, uh, and the person standing at A, he can see the ranging rod at point A, he can see the ranging rod at point B, and the person standing at the intermediate point moves the ranging rod left and right, and this person lets him know when the three ranging rods are in alignment. So he can basically see just one ranging rod. So that is when he would know that the three are in one line, and then you can fix this intermediate point. Now you can do this with naked eye if you don't have any instrument, or if you have a theodolite or an auto level, so an instrument that has a telescope and that has a bullseye, so you can do this with much more accuracy. So this is direct ranging when the initial point and the final point are intervisible, so we can use this method. But when the 2 points are not indivisible, then you need to improvise. You need to have some other methods by which you can do the same process, and that is where indirect ranging comes in. So we have two different types for that: reciprocal ranging and the random line method. So we'll discuss them one by one. In reciprocal method, what we do is, let's say you have the first point, point A, and the second point, which is the last point, is point B. So when you're standing at A, this point is not visible. And when you're standing at B again, the point A is not visible. And you need to set up points between these two, and all the points have to be in a straight line. Why they need to be in a straight line? Because that they will give you an indication that whatever work you're doing standing at either point, you are in the same in one direction. Because if, let's say, you start measuring distance between point A and point B, so starting from point A, you could probably go anywhere. Your direction could be very wayward. But if you have those intermediate points, it will make it very easy for you to measure distance. So since the 2 points are not visible, so what can be done is that you select 2 points between the point A and point B, and you select them in such a way that when you're standing at this point, which is a newly created point, point C, you can see point D and point B as well. And when you're standing at D, you can see C and A. So what we try to do is that these 2 points C and D are created by rough idea. And when you're standing at D, you can see A, which is fixed, point A and B are fixed, but point C and D can be moved, and they will be moved until all these points are in a straight line, and that is when you will fix them. So when standing at D, you will fix the position of C because you can see A. And when you're standing at C, you will fix the position of D because you can see B. And this process will keep going on every time you will shift point C and point D a little until after a number of trials, the 2 points will be in the straight line, the line which joins point A and the point B. So this is iterative process. Alternatively, we can use another method which is called as a random line method. So let's say you want to erect a point between B and R, but there are a number of obstructions between them so that it's difficult for you to do direct ranging. So what we can do is that we can create another point, point Q, from which B is visible and R is visible, and we create in such a way that we get a right angle triangle where 90 degrees is at the point Q. So once you have done that, now what we can do is we can measure the distance Q and R, and we can measure the distance Q and B. So once you have that, you can measure the distance B and R as well. B and R is basically the hypotenuse, and we can measure that. Uh, so now what really needs to be done is that we need to locate 2 points between point B and R, the intermediate points. So that is basically what ranging is. But by doing this, now we have another option. So let's say on this line, I select two random points. Let's say I select one point over here and I select another point over here randomly. So on those 2 points, if I draw a perpendicular at 90 degrees, so that line would be parallel to this line. So that means that line would intersect this line BR at some point. And basically we need to find out what that distance is at which that perpendicular will intersect this line BR. And if you can correctly find out that distance, you can correctly find out that point which will be in alignment with B and R. So let's see this in the figure. So let's say the two random points that you selected were X and Y, and you drew perpendiculars at 90 degrees, and the only thing that needs to be done now is to find out that cutoff. So if we can calculate that distance correctly, x, x1, y, y1, wherever that distance will be, the two newly created points will be in the same line as B and R. So how can we calculate the distance x, x1? This is where the similar triangle theory would come in. So what does the similar triangle theory say? That if you have this triangle, the ratio between two sides of the triangles will be same. So if I see this first triangle BX and X1, and I consider the other triangle as BQ and R, so that means the ratio of two sides QR over BQ would be equal to XX1 divided by XB. But the side that I'm really interested in is finding out this distance XX1. So if I consider again the two triangles, and I take into account this distance xx1, so that would mean xx1 divided by bx is equal to qr divided by bq. Now if you see this equation, the only unknown is xx1. I can measure xb, I can measure bq, which I've already done, and I can also measure qr, so and bq, so those were already calculated. So if you plug in these values, and you can find out xx1 and yy1. And once you have these two distances, you can create a perpendicular at point x and a perpendicular at point y. And at the distance that has been calculated, you will erect one point over here, y1, and one point over here, x1. And in the end, b, x1, y1, and r will all be in alignment in a straight line. So this is how you can carry out ranging if the first point and the last point are not indivisible. So we improvise. So that's it for the first lecture. And let's meet in the second lecture.